Here we have the 2016, this is question 11, this is paper 2 and junior cert ordinary level, and we're doing a question on trigonometry. So Seamus is making an access ramp for a building. The ramp is in the shape of a right angle triangle, so I've just drawn the triangle that they've given us in the diagram. The diagram of the ramp is shown below, so I've just drawn it, and the lengths of two sides are shown. The angle A is marked. So write down the length of the side adjacent to A. So firstly, I'm going to walk you through, say, when we have a right angle triangle, we need to know what side is the opposite, what side is the, say if we deal with an angle, this angle here, what side is the opposite, the hypotenuse, and the adjacent. So they're the three ones we need to know. We need to know the opposite, the hypotenuse, and our adjacent. So the hypotenuse is always going to be the longest side. It is the side opposite the right angle. So if we look at what's the longest side and the side opposite the right angle, so if we draw a line from the right angle to a side, well, this is a side opposite it, so it's a side opposite the right angle. So try not to get confused. The opposite side is the one opposite the angle we're talking about, but the hypotenuse is opposite the right angle and it's the longest side. So this one is the hypotenuse. The opposite is the one opposite the angle we're talking about. So this is going to be the opposite one here. And then the one that's left, adjacent means beside. So the one that's left is the one that's going to be beside the angle, but it's not the hypotenuse. So this one here is going to be the adjacent. So now that we know what hypotenuse, opposite, and adjacent, we can figure out which one is which. If we look at this triangle here, so we want to figure out the side of the length of the side adjacent. So the adjacent is going to be 260. So this side here, I'll just write in adjacent here. The opposite is going to be the side opposite the angle A. So if we look at the side opposite, it's going to be this one. So this is our opposite. And then the remaining is the side opposite our right angle and the longest side, which is the hypotenuse. So now we have our sides labelled, and we're asked to write down the value of tan of A as a fraction. So if we want to figure out what tan of A is, we can use our log tables, and there's a rhyme we can do as well. So firstly, if we're using our log tables, so tan of A is equal to whatever the angle is. In this case, the side A is the opposite, and then the side B is the adjacent. So in general terms, tan of an angle is equal to the opposite over the adjacent. There is a rhyme that we can learn off if we don't want to use our log tables, but we have our log tables in the exam, and the rhyme is so ka toa. That stands for the sin is the opposite over the hypotenuse, the cos is the adjacent over the hypotenuse, and the tan is the opposite over the adjacent. But we can check and use our log tables as well. So if we're asked to get the tan of this angle A, so the tan is our opposite over our adjacent. So our opposite we got was 20, our adjacent is 260, so the tan of our angle is equal to 20 over 260, and we can actually break that down a little bit more. Say if we just put 20 over 260 into our calculator, we get 1 over 13. So we could simplify it a bit, and we get tan A is 1 over 13. So that is the angle of tan A as a fraction. And then the next part is use your answer to find the size of the angle A. So we are after getting that tan A is equal to 1 over 13. So if we know what the tan of the angle is, but we want to get the angle. So to get the angle, in this case, we have to do the tan inverse 1 over 13. So to get the inverse, we have to go shift and then we press tan, and then we have a -1 kind of button at the end, and then we go 1 over 13, and then we close our bracket, and then we get 4.398. So A is equal to 4.398. So they say give your answer correct to the nearest degree. So the correct to the nearest degree, A would be equal to 4 degrees. And then in part 4, the angle A must be less than 5 for the ramp to be acceptable. Is Seamus's ramp acceptable? So the angle is 4, well it's really 4.39, but it's less than 5 anyway. So as we can say, yes, it is acceptable as the angle is less than 4. The angle is 4 and it's less than 5. The angle is less than 5 degrees. So we can say that the ramp is acceptable for that purpose. So that is our answer for that. Thank you.